Hola, Algebra students. This is Ms. Carranza, and today we are going to start talking about the second part of Lesson 8.4. And the notes today are solving quadratic equations by factoring. But again, this is part 2. So we are going to continue studying how to solve quadratic equations by factoring. Okay, please pause the video right now so you can write down the heading on a separate sheet of paper. And you can push play when you're ready to begin. Okay, the next things that you want to write are these two. Set your quadratic equation equal to 0. That is super, super important. When you are solving quadratic equations, it is very important to make sure that you have it set equal to 0. For example, if you have a quadratic, a linear term, and a constant term, have them on one side and the other side be 0. You can also have the 0 on the left side, and then your quadratic terms, linear terms, and constant terms on the right. My suggestion, though, is to always make sure your quadratic term is positive. In order to guarantee that, if you have quadratic terms on both sides of the equal sign, cancel the smaller quadratic. That's only if you have a quadratic term on both sides of the equal sign. We used to use that rule when we were solving linear equations. You'll understand what I mean once we do a few examples. Please pause the video now to write down everything that we just discussed. Push play when you're ready to begin. Okay, here is our first quadratic equation. If you notice, there are terms on both sides. There's also a quadratic term on both sides. We are going to move the smaller one, or whichever one has the lesser value. When I ask you to move the smaller one, I'm asking you to think about a number line. -1 y squared, so -1 is smaller than +2 y squared because -1 is smaller than 2. And by smaller, I mean has a lesser value. So if you have quadratics on both sides of the equal sign, you're going to move the smaller one, cancel it. So because it's a positive y squared, I'm going to cancel with, since it's a negative y squared, I'm going to cancel with a positive y squared. I'm going to do the same thing to the other side. Feel free to put a 1 in front of a y squared. Bring everything else down, combine like terms on the right side. Now remember, our goal is to set the quadratic equation equal to 0. So since I'm moving everything to the right side, I'm going to continue with that. I'm going to cancel positive 31y with a negative 31y, so that it gives me 0. You always want 0 on one side. And then you have 3y squared minus 27y. This is when you now start factoring if possible. Remember to always check for GCF. These two have a GCF of 3y. Bring down the 0, put the GCF in front, and the remainder be y minus 9. At this point, you want to set each linear factor equal to 0. Now be careful, because this looks like a difference of squares, but your variable y doesn't have a squared. If it had been y squared minus 9, I could square root both of these terms and write it as y plus 3 and y minus 3. But this is not a square. Y does not have an exponent of 2. So your two solutions, if you finish solving, are 0 and positive 9. So the first part of the problem is to get all the terms on one side. 0 has to be on the other side. The second part of the problem is to factor and solve, if possible. Remember that you can pause and rewind the video at any moment if you need to go over something that I talked about. Okay, go ahead and write down example number 2. Pause the video and ask yourself, what side do we have to move all the terms to? What side will the 0 be on? Go ahead and pause the video. Push play when you've answered those two questions. What side are we moving the terms to, and what side will the 0 be on? Because there are quadratics on both sides, we are going to cancel the smaller one, which means that I'm going to be collecting all the terms on the right side. Be careful, because you have a negative 25 that you have to bring down. Since I moved everything to the right, well, since I moved the quadratic term to the right side, that means everything has to go to the right side. I'm going to cancel the negative 25 with a positive 25. Now, 25 does not have a variable. That is a constant term. That's going to go after the quadratic and the linear term. Remember, 25 did not have a variable, so it was not a like term to the other numbers that were already there. So that's the first part of the problem. Get all the terms on one side of the equation, 0 on the other. So now we're going to factor and solve. There is no GCF here because the only number they could divide it by is 1. But this is a quadratic trinomial. So I need to find two numbers that multiply to 25 and add to negative 10. Take a minute and figure out which factors of 25 would work. Check your positives and your negatives. Pause the video now, do that on your own, and then push play when you're ready to continue. The correct factors are negative 5 and negative 5. I can use the shortcut for factoring here because my leading coefficient was 1. The two numbers that are found were negative 5 and negative 5, so I put them in parentheses as binomials x minus 5 and x minus 5. Now I'm going to set them equal to 0, but since they're the same exact binomial, you don't have to solve both of them individually. They're going to give you the same answer. So you really only need to solve it once. Your solution here is 5. Okay, go ahead and start writing example 3. Again, when there's a quadratic term on both sides, you're going to move the smaller one. Now, it's been coincidence that the smaller one was always on the left. That's not always going to be the case. So move the smallest quadratic, and that tells you what side you're going to move all the terms to. So since the smaller quadratic was on the left, that means we need to move it to the right. So you're going to be collecting everything on the right side. Keep going. Keep canceling things from the left. Notice that I'm keeping like terms with like terms. So 5n gets subtracted, give you 0 on the left. On the right side, I combined the negative 5n with a negative 5n. Okay, so that's the first part. Get all the terms on one side. The second part is to factor and solve. So I want you guys to notice that the leading coefficient is 1, so the only GCF they have is 1. You're going to find factors of 14 that multiply to negative 14 but add to negative 10. So pause the video and tell me which factors will multiply to negative 14 and add to negative 10. Pause the video, do that now. Hopefully you realize that this cannot be solved by factoring, because there are no factors of 14 that will multiply to negative 14 and add to negative 10. We will learn how to solve this. We just can't do it with factoring. Make sure you're not saying can't do it or can't be solved or no solution, because it does have a solution. We just don't know how to find it yet. The only strategy that we've reviewed is solving by factoring. So you have to say can't solve by factoring. When you're ready, go ahead and start writing the next example. Okay, for the first time, we have quadratics on both sides, but the smaller one is on the right. So that's the one we need to cancel. Since it's a negative 4w squared, I'm going to add 4w squared because that'll cancel it. I'm going to combine it with a like term on the left side. Because I'm canceling from the left and moving it to the right, that means that all the terms are going to be collected on the left. So we're canceling from the right side and moving it to the left. Remember, since the smaller quadratic was on the right and we moved it to the left, we want to move everything else to the left. So I'm going to keep going and moving things to the left until there's nothing left on the right side. This happens to cancel also. At this point, you want to solve by factoring. There is no GCF between 81 and 16, but that's something that you guys are supposed to do no matter what. 16 over 81 comes out the same, so that means the GCF is 1. So there is no GCF besides 1. But this is the difference of squares. You can square root 16, you can square root w squared, and you can square root 81 without getting a decimal. So this is a difference of squares. It breaks up into two binomials, one with a plus, one with a minus. The square root of 16w squared is 4w, and the square root of 81 is 9. So my two factors are 4w plus 9 and 4w minus 9. Now I'm going to set each of these equal to 0. And solve. Go ahead and pause the video, solve the two equations, and then check your answer by pushing play. Okay, hopefully you didn't cheat and just pushed and then kept going. I hope you pushed pause when I asked you to. When you're ready, go ahead and write down example 5. This equation does not have a quadratic on both sides. There's only a quadratic on the left side. You always want to keep your quadratic term positive. So if there's only one and it's already positive, leave it there. If you have quadratics on both sides, you want to move the smaller one. Since my quadratic term is already positive and on the left, I want to keep it there. So I want to keep all the terms on the left side so that my quadratic term is positive. That means I want to cancel things that are on the right side. Remember, you have to use opposite signs. So if I want to cancel 6m, I have to subtract 6m. That's the only way to get 0. So again, you cannot solve by factoring until you have 0 on one side of the equation. We already decided we're going to collect things on the left side, so I have to keep going. Once I have the 0, I can start factoring. This quadratic trinomial does not have a GCF, but I need to find two numbers that multiply to negative 36, that comes from 2 times negative 18, and add to negative 9. Pause the video, list all the factors of 36, and find the two factors that multiply to negative 36 but add to negative 9. Push play when you are ready. Pause the video now. Okay, the two factors that you have to use are 3 and negative 12. Because the leading coefficient is not a 1, I need to factor this by splitting the middle term using the two numbers that you found, positive 3 and negative 12. Put an m on both of them. Remember, we put an m on both of them because if I wanted to, I can combine like terms and go back to the original problem. So these two expressions should always have the same value. Remember that factoring doesn't change the value of a problem, it just changes what it looks like. Okay, I'm going to find the GCF of the first two and the GCF of the second two. Please pause the video, find the GCF yourselves. Push play when you're ready. Okay, the GCF for the first two terms is m. The GCF for the second two terms is negative 6. The remainders after you divide each of these, remember your remainders should match. And in this case, it would be, my negative erased, okay. Should be 2m plus 3. Okay, pause the video, go ahead and set each of these equal to 0 and find the other two solutions. Push play when you are ready. Push pause, solve them, and then push play when you're done. Your two solutions are negative 3 halves and positive 6. Okay, go ahead and write down example number 6. Remember, when you are solving quadratic equations, it's important to look at the terms that are on both sides. If you have a quadratic term on both sides, you need to cancel the smaller one. If you're not sure which one is smaller, draw a number line. Negative 6 is more to the left than negative 1. Remember on the right side over here, there's a negative 1 in front of the y squared. Whichever one is more to the left is smaller. So that means that the negative 6y squared has to move to the right side. Since we're moving the smaller one to the right, we need to move everything to the right. And when you move them, you're using your rules of canceling. So that 16y needs to be canceled with a negative 16y. And make sure you're combining terms correctly. Okay, negative 4 will turn into 0 if I add 4, which is great because when you're solving by factoring, you want all your terms on one side. Notice that the 4 does not have a variable, so it cannot combine with anything that was already there. Always check for GCF. Unfortunately, 5, 12, and 4 don't all have the same variable, and there's no GCF besides 1. But it is a quadratic trinomial, so I need to find two numbers that multiply to 20 and add to negative 12. Go ahead and pause the video right now. List all the factors of 20 and find the two that will add to negative 12 and multiply to 20. Push play when you are ready. Okay, the factors that would work are negative 2 and negative 10. Since our leading coefficient is not a 1, I'm going to rewrite this as 5y squared minus 2y minus 10y plus 4. Remember that factoring changes what a problem looks like, but it does not change the value. So if I wanted to, I could combine like terms, negative 2y minus 10, and that would give me the original negative 12 that I had, negative 12y. Now you're going to separate them into pairs. Please pause the video now. Find the GCF of the first two and find the GCF of the second two terms. Push play when you are ready. You should have gotten y minus 2 in your first binomial because the GCF of the first two terms was y and the GCF of the second two terms was negative 2. The remainders would be 5y minus 2. Set each one of these factors equal to 0 and solve. Remember guys, if you need more help or you have any questions, please send me a message through Remind. And I will be more than happy to help you. Your two solutions here would be positive 2 and 2/5. What I recommend now is trying some of these problems again on your own, either today or tomorrow, without watching the video. So again, my recommendation is try these problems again on a separate sheet of paper without watching the video and seeing how you do. Send me questions on Remind if you have any. Okay guys, good luck. See you soon.